Hi, fellow students of Berkeley. My name is Jeffrey Ha, and today I want to introduce the course CBE179, one of my favorite courses I enrolled in during my undergraduate program at Cal, specifically in the spring 2021 semester. This course is taught by Professor Roy Mabudian and has been very helpful to my professional and academic growth. I plan to explain the course's main purpose and scope, and ultimately encourage a lot of you guys to enroll in the class. CB179 is a course that primarily goes over the fundamentals and applications of various microfabrication techniques and familiarizes students with the semiconductor industry. As many of you know, solid state technology provides the fundamental building blocks required for our current and future information revolutions and has grown into one of the largest industries today. In particular, semiconductors are used in everyday electronic gadgets, ranging from phones, laptops, automobiles, and other satellite related devices. Many companies, including but not limited to those on the right, are massive producers in the solid state device market. The estimated revenue of products that contain chips is worth tens of trillions of dollars. However, since most of these huge technology firms are well known, the general public often overlooks the big players behind the scenes. A large majority of the consumers at the top of the the value chain pyramid, purchases chips and transistors, which are all solid-state devices from the companies below. And all these companies hire many chemical engineers. To gain insight on how the semiconductor and any related product industry will grow in the future, it is very useful to recognize how all these companies play together. Chip fablesses design chips, which are then produced by chip foundries. Most of the technology that these large corporations use is often sourced from smaller firms that specialize in fab equipment engineering, petrochemicals, and silicon production, and also design automation techniques. To understand how all these various players come together to provide us with semiconductors, one must learn how all these unit processes come together. Chemical engineers have particularly been helpful in developing and further optimizing these unit processes, and it is now our turn to continue the semiconductor technology revolution. UC Berkeley, and notably the College of Chemistry, is deeply rooted in the semiconductor business. Gordon Moore and Andy Grove are both well known names and have previously led Intel to become one of the biggest semiconductor corporations in the world. One of the reasons why UC Berkeley has grown into a semiconductor powerhouse is because of the rigor of chemical engineering fundamental courses and the diverse portfolio of elective courses. For those who are interested in energy and material science, CB179 is a great course to enroll in. Many students familiarize themselves with quantum mechanics, electronic structures, thin film deposition chip characterization techniques, so that they are prepared in conducting research or going into the industry workforce. Historically, many Berkeley alumni members have found jobs at semiconductor firms that commercialize breakthrough technologies and mass manufacture solid state devices. I would like to dive into CBE179's curriculum and further elaborate on how this course prepares students both in academia and in industry. The course is divided up into three large sections. The first two are more on the fundamental knowledge on semiconductors, about one third of the course, and the last two thirds on microfabrication techniques. While prior coursework in thermodynamics, chemical kinetics, transfer phenomena, and quantum mechanics are recommended, most of these concepts covered in class are very elementary in difficulty. There are three non cumulative exams in the course, all of which aren't too difficult either. Now, of course, just like any other class, many of you may have doubts and concerns whether or not you should enroll. I would like to take the time to elaborate upon some common concerns students have prior to enrolling and further persuade you to all take the class. I took this course, CBU 179, in my junior spring semester, and I too was intimidated by the seniors and few graduate students. Since juniors typically don't have any experience with electronic materials, it is normal for younger students to feel insecure with their knowledge. However, even without any prior knowledge in the discipline, once you finish the course, you would be able to outline the different sub-processes required to manufacture modern semiconductors in detail. The professor and GSIs are also very helpful, and they both host weekly office hours. Quantum mechanics is a discipline that most chemical engineering students here at Berkeley struggle with. Physics 170A and Chem 120A are both classes that are difficult and don't really provide the best intuition for quantum mechanics. While CB179 still builds off the same basics as those two classes, the difficulty of the quantum mechanics section is around one third that of the mentioned two classes. The instructors understand that students often struggle with this section, so the homework solutions will also be released prior to the due date. Regarding midterms and final exams, although 3 exams may seem a lot, these exams are very doable. There are 3 non-cumulative exams in the course that equally contribute to the final grade. Considering how upperclassmen tend to enroll in many technical courses, the final midterm will be on the last day of class, or the week before dead week. Most of the questions are time crunch questions, but if you solve all the homework questions, there should be no huge difficulty in acing these midterms. Lastly, some of you guys may worry whether or not CBE179 is a worthwhile course for you to enroll. This is because for those who are considering going to the semiconductor and electronics industry, there are many other courses similar to CB179. Most of these courses are often offered through the College of Engineering and can also work towards elective credits. CB179 fulfills a specific niche among these classes because it does not have a lab and project portion like E143 and doesn't really focus on theory and electronics like how Physics 141 and MSc 111 do. Okay, so this class sounds pretty appealing to those who are going to semiconductors, but what if you aren't? Matter of fact, I too, at least for now, am not, and I'd like to give a brief summary of my past experiences. During my undergraduate career, I focused on several research areas. First, I interned at an optics company, manufacturing microscopes. I then researched concrete and their mechanical and electrical properties, consulted chemical companies on various electrolysis and petroleum projects, and ultimately I hope to develop various catalysts during my electrocatalysts during my graduate studies. While I haven't directly experienced the semiconductor industry, I soon realized that microfabrication techniques are found ubiquitously in many subdisciplines around us. Although seeming distant, microfabrication is also an essential part in biotechnology and pharmaceuticals when developing drug delivery methods and biosensors. So, the punchline here is that CB179 is a great course to enroll in, regardless of your specific field. Many jobs and titles at the companies below recommend people to learn about microfabrication processes, so I would highly recommend everyone to join the class. Thank you for all listening to my presentation, and I will just end the presentation by quickly showing the syllabus of the class.